Assalamualaikum and a very good day to our lecturer and friends. We are from Bmmm students, and today our group will be present about torsional loading evaluation from actual structure under solid mechanics. Let me introduce my members group. First is me, MUHAMAD HAFIZI. The second member of our group is FARIS IRFAN, and our last member is Amzar. For your information, torsional test is a test that twists a material or test component to specified degree with a specified force or until the material fails in torsion. The twisting force of a torsion test is applied. The rotary moment may also be applied to both ends of the sample, but the end must be rotated in opposite direction. There are a lot of structures that link to torsion, such as door handle, fishing rails, and more other things. For our group, we choose which is L handle socket. The basic experiment for the course is how to loose and tighten the screw of the tire. When we choose this structure, which is L handle socket, we must explain the objective of our experiment. First is to determine the behavior of material or a test sample exhibit when twisted or under torsional force. The second one is to determine the modulus of elasticity in shear, yield shear strength, torsional fact life, ductility, ultimate shear strength, and lastly, a modulus of rupture in shear. There are only two objectives of our experiment. So for the next step is the result and calculation.
As you can see here at the right picture from the slides, we can see this is the actual situation in which we are trying to open a bolted nut by using a L handle socket. And at the middle of the photo, we can see this is the free body diagram in which we are trying to open up a bolted nut by using a wrench. As you can see from the diagram, we can see there are moments, force, distance and right angle from the wrench. And lastly, at the left side of our slide, we can see this is the dimension for the L socket. Right. The first material that we are using that are tested are my steel, and the shear modulus G is 78 gigapascal, and other than that, the length LA, LB, and the diameter are the actual lengths that we got from the L handle socket. Okay, so first one, polar moment. So the formula for the polar moment are J is equal to pi over 2 times C to the power of 4. Alright, as you can see, C is the length from the L socket to the nut that we are going to open up. Alright, so as you can see, C is equivalent to LB, in which 60 millimeter, and we have to convert it to meter, and then the answer should be 0.006 meter. And then after we summarize the equation, we got the answer J is equal to 2.03362 times 10 to the power of -9. Right. Second of all, we're going to calculate the maximum shear stress, which is tau is equals to TC over J. Right. As you can see, from this equation, we are not going to find the value of tau, but we are going to find the value of T, which is the torsion. Right. So as given, tau is equivalent to shear modulus G, and in which we are going to put on tau 78 times 10 to the power of 9 is Newton meter squared is equal to T times C, in which the same value of LB is over to the J, in which J are the values that we are conducted from the previous polar moment. Right. So after we summarize up the equation, we got T is equal to 26.468 kilonewton per meter. Right. So to summarize up, we are going to find the factor of safety Fs Right. Before we're going to find the value of the factor of safety, we are going to find the value of F first, in which from the left side of our slide, we're going to find the value of F from the distance from the L handle socket. Right. So as we can conclude, LA is equal to 0.2265 meter, and the moment that we have been calculated is equal to 26.468 kilonewton meter. Right. And then we can summarize up. We can put the value of moment, the value of moment is equal to 26.468 times 10 to the power of 3 plus F, which is multiplied by 0.2265 equals to 0. Then after we summarize up, we got F is equal to 116.87 kilonewton. So back to the factor of safety. So the formula is tau maximum divided by the tau actual. Alright. So So the third value that we have to summarize. So the third value that we have to conclude. So lastly, the third value that we have to pick up from the internet is the value of maximum torque for nut size M16, in which T is equal to 248 Newton. So after we insert the value of T max and over to T actual, so we got a value of 206.734, in which from the calculation above, the rotating mechanism is safe for working condition, in which the force that we applied for the L handle wrench is safe for us to use. So that is all from me. Thank you.
The discussion of this experiment is when a torque is applied to the structure, it will twist along the long axis of the rod and its cross-section remains circular. The more angle of twist, the larger the shear strain. Okay, we can immediately learn a few things from this equation. The first thing might be obvious. The more angle of twist, the larger the shear strain. Second is, this is the big difference between axial loaded structures and torque loaded ones. The shear strain is not uniform along the cross section. It is zero at the center of the twist rod. Finally, the longer the rod, the smaller the shear strain. If you look at here, the equation, the meaning of the T is the applied torque, L is the beam length, G is the modulus of rigidity, shear modulus of material, and J is the torsional constant force. Hence, from all provided, we can determine the modulus rigidity by measuring angle of a twist, torque, length, and diameter. For the conclusion of this experiment, we can conclude that we are able to analyze the deformation of the circular shaft when it's subjected to torque. We also learned the test method to obtain the shear modulus of elasticity for material and how to calculate the factor of safety for the L handle socket. The maximum force of the shaft then to break are able to calculate it, and also the way of working or being called their body diagram FBD shows how the tools apply the momentum force toward the tool what are being examined. Thank you.